Hey, this is Simon's here. I am going to do the video 416 notes. So, in this unit, you're going to learn how to use the fundamental identities to do basically four things. So to evaluate trig functions, to simplify trig expressions, to develop additional trig identities, and to solve trig equations. So that is the purpose of this unit that we're working on right now. So we are going to be using the fundamental identities to calculate this. It says use the values that secant u is equal to -3/2 and that tangent is greater than 0. So if we were thinking about the coordinate plane, secant is the reciprocal of cosine. Cosine is negative in the second and the third quarter. Tangent is positive in the first and the third quarter. So this triangle is being built here. So we know that secant is -3/2. That means cosine is -2/3. That means this side is 3. This is -2. And we need to do the Pythagorean theorem to find this y value. So -2 quantity squared plus y squared is 3 squared. So I'm going to get y squared is equal to 3 squared minus that's -2 squared. 9 minus 4. I didn't mean to put that equal sign there. So we square root both sides and we get y is equal to the square root of 5. In this third quadrant, this is going to end up being a negative square root 5. So we have negative square root 5 over the hypotenuse for sine. Cosecant is going to be -3 over the square root of 5, but that has to be rationalized. So we are going to multiply by square root of 5 over square root of 5. This is going to give me -3 square roots of 5 over 5. Tangent, remember, is opposite over adjacent. Opposite is negative square root 5. Adjacent is 2 and -2. So this ends up being a positive square root 5 over 2. Cotangent is that reciprocal. Again, it has to be rationalized. So this is going to be 2 square roots of 5 over 5. All right, go ahead and pause the video and try this next one. All right. So again, on a coordinate plane, cotangent and tangent are both negative in the second and the fourth quadrant. Sine is positive in the first and second quadrant. That means that my triangle must be over here. So cotangent is -5. Its reciprocal, -1/5, would be tangent. In this quadrant, the y value will be positive, the x value will be negative, and tangent is y over x. So y is 1, x is -5, and again that has to be negative for x because that's what x is in this quadrant. Then I have 1 squared plus -5 squared is equal to r squared. This is going to give me 1 plus 25. So r is going to equal the square root of 26. So that's what goes here. So we know sine is the square root of 26 over 26. Technically, this is y over r, so cosecant would be r over y. R is square root of 26 over 1, gives me square root of 26. Cosine is going to be negative 5 over the square root of 26, which needs to be rationalized. So we're going to multiply that by the 26, top and bottom. So negative 5 square roots of 26 over 26. And secant is going to be this guy's reciprocal. So this is going to be negative square root of 26 over 5. Again, we have done all of the front of this multiple times so far. All right, going to the back. It says simplify this trig expression. So the first thing I am going to do is I'm going to factor out a sine x. That's going to leave me cosine squared x minus 1. I need to find my identities because I don't have them right here handy. Hold on. I don't remember when I handed them out. Oh, actually, it was supposed to stay. Well, I don't have them handy. Anyway, cosine squared x minus 1 comes from the Pythagorean identity, sine squared x plus cosine squared x is equal to 1. To get this to look like cosine squared x minus 1, we are going to have to subtract 1 from both sides, and then we will have to subtract sine squared x from both sides. On this side then, I have cosine squared x minus 1, and that is equal to negative sine squared x. So this can be replaced with negative sine squared x. Well, that is going to give me a negative sine to the third x, and that one is done. Alright, so here I have secant squared x times 1 minus sine squared x. This again is coming from the Pythagorean identity, sine squared x. If I subtract sine squared x from both sides, I would end up with cosine squared x is 1 minus sine squared x. So I can replace this with cosine squared x. So this is secant squared x times cosine squared x. Well, secant is the reciprocal of cosine, so I could rewrite this as 1 over cosine squared x times cosine squared x over 1, which is going to give me cosine squared x over cosine squared x, which is 1. Alright, so the next two say to factor. This is technically difference of squares, which we learned as a squared minus b squared is equal to a plus b, a minus b. So here, I'm going to have secant theta plus 1 times secant theta minus 1. And it's done. It just asks you to factor it. Here, you might want to think about using u substitution, where u is going to equal tangent theta, because this is going to be 4u squared plus u minus 3. And then you have to go back and remember how to actually factor those. The way that I taught you was that reverse box method. 4u squared goes there, negative 3 there. That multiplies to negative 12. So negative 12, I'm going to have a positive 4 times a negative 3. So a positive 4u, negative 3u. Here I'm going to have 4u minus 3. Here I'm going to have u plus 1. So instead of u, remember u is tangent. So I'm going to have 4 tangent theta minus 3 times tangent theta plus 1. And again, that is factored. Go ahead and pause the video and try these two. This one has a cotangent squared on both of them, so I'm going to factor that out, and that's going to leave me 1 minus cosine squared x. Well, cotangent could be written as cosine squared x over sine squared x, and 1 minus cosine squared x can be written as sine squared x, technically over 1. Those two divide each other out. That leaves me cosine squared x. Here again, I'm going to use u substitution, and I'm going to call u sine u. So I'm going to have u squared minus 3u minus 10. And that is going to factor to u minus 5 times u plus 2. Because the factors of a negative 10 are 5 and 2. They differ by 3. 5 is larger, it gets the negative. So this is going to become sine u minus 5 times sine u plus 2. That's it.